So hi guys, welcome to lecture 4 of Python. My name is Pranav and I'll be your lecturer for today. So if you have any questions during the lecture, feel free to ask in Py questions. I'll be looking into it as well, and I'll be answering them. So before we move on into today's class, we'll have a look at the homework that I assigned you for last week. So let's look at the first question of last week's homework. So you were asked to get a string as an input from the user. Just a minute. Yes, and cool. So you're asked to get a string as an input from the user and check whether the string is a palindrome or not. So a palindrome is something that when written backwards or forwards spells the same. For example, the word noon, if you spell it backwards or forwards, would spell the same. So the way the solutions to this program would go like this. So I'm using something known as Jupyter Notebooks. I felt it would be much better to illustrate the concepts to you via Jupyter Notebook rather than Replit. So I'll be using Jupyter Notebook for today's lecture. So let's look into how we can solve the program. So we declare a variable x which takes an input a string from the user. So we say enter string. Okay. So what we do is we can check, if x dot lower. So this is because for example, if the user says inputs radar as the string, if we reverse the string, it would be say this. So it would obviously say it's not equal to each other. So it would be better that if we convert the string into lowercase, so it's easier for comparison. So that's why we're doing x dot lower, and we would equate this to the reverse of x. So if you looked into last week's class, you will know that this essentially reverses the whole string. So this, we have three inputs, which is the start value, the end value, and the step value. So the start and step has been declared as null, so it will take in the whole string. The -1 essentially reverses the whole string. So we lower this and we check whether they both are equal. If they are, we print is a palindrome, and if not, we say is not palindrome. Cool. As this should work. So for example, it says radar, it says radar is a palindrome. Planar, it says planar is not a palindrome. Yeah. So this essentially reverses the whole string. It's a very easy method to reverse the whole string. So all you have to do is initiate the step value to be -1, and this essentially reverses the whole string. So that's it for the first program of homework 3. We'll look into the second one. This is a bit of a tough one, and I noticed a few of you implemented in a few different ways. So we'll see how this can be implemented. Okay. So you requested to read an email ID from the user and ensures that it belongs to the domain @gmail.com, and if it does, I want you to say the domain is correct, and if not, say the domain is incorrect. So if we take in the email ID, we say and we declare a domain to be @gmail.com. So this is essentially what we want to check whether the domain is. So this is one way of doing it. So what we do is we take in the length of the email ID, and we also take the length of the domain. So ID len takes in the length of the email ID, and dom length takes in the length of the domain. So you could use different functions like the dot ends with, but using what you've learned so far, there is a neat way of checking whether the domain is @gmail.com, which is using slicing. So how you would do this is essentially check whether the domain is equal to the email ID sliced to this. So to show you how this works, I'll just type out the program here. Okay, maybe, okay, let's see. So what the statement does is, yeah, so it subtracts the length of the email ID to the length of the domain. So basically, if the email is say bob@gmail.com, the length of this would probably be 13, I guess, and our domain is @gmail.com, so which is I think just 10. Okay, it is the length of thing. So subtracting both of these would essentially give us 3. So what happens is, when we start slicing from 3, Bob, we only look at from@gmail.com. So let me just print this to illustrate this much better. Let's say bob@gmail.com. You notice that it slices @gmail.com to check. So even if I type it slices the @gmail.com part out. So what it does is it subtracts the length of the email ID and the length of the domain. So this is the length of the email ID, the length of the domain would be this. So subtracting this would essentially mean you printing from or from this. So this would enable us to check whether the domains are equal. So that's what we will be doing here. We would check if domain is equal to email ID and ID of length minus length, and print is correct, else the domain is incorrect. Yeah. So if I enter the domain, it should say the domain is correct, and if I enter something else like yahoo.com, it should say the domain is incorrect. So one easier thing is try to keep hardcode strings. So if in case I want to change the program to say check whether it belongs to yahoo.com, I could just do this. So yeah, so try to declare variables to store most of your conditions, because it's easier to change whenever you want to, rather than hard coding strings. So essentially, when you program, it's a good practice that you store stuff that you might change in the future in variables like these. So if I want to modify the program, I could just modify this sentence rather than changing the whole program. And that's it for last week's homework. So let's look at a handy function that will be useful to you guys in the future. So what if I want to let's say I take in a string and I want to take in all the words in it and make it into a list. So let's say the string is yeah. So if this is a sentence and I want to make a list which has each of these words as its element, so Python has this handy function called the split function. This is the split function. So what the split function essentially does is it splits the string based on the spaces. So if so the function goes like this: it looks into the string, if it finds a space, it splits this and makes this into an element. It moves on, checks to the next space and splits this word. It goes on splitting each word based on their spaces. So to illustrate it better, to show that the split function splits spaces are found, let me just copy this let me just leave no space to be here. Let me just leave space between lazy and dog. So now if I split, just a minute. Okay, you can see that it splits only where the space is found. So essentially the function only splits where in the string where the spaces are found. If the spaces is not found, it's not going to split this string. So you might expect it to split with each word. It's not going to do that because it doesn't know if there is a word or quick is a word. So the split function essentially works on spaces in a string and splits where spaces are found. This is a handy function which will come into use when you program later. Okay, so we'll go through loops now. So loops is an interesting concept in Python, which I think is one of the core basics of a lot of programs that you might be building in future. However complex a function might be, it probably would include a loop, a if or else statement, and a function. So a loop is such an important basics to be thorough with, so that you can program complex things. Okay, so loops basically, let's say I want to print the numbers 1 to 5 in each line. The obvious thing would be to do this, say 1 /n. The /n command essentially makes a new line, 2 /n3 /n4 and /n5. This would print 1 to 5 in each line. But let's say I want to print the numbers 1 to 100 in each line. What would I do then? It's a very difficult task to print each number till the 100 and append a /n to it before. So Python has this simple concept called a loop. A loop, as the name suggests, is something that repeats over and over again, and loops in Python also operate with the same logic. So there are two different types of loops. You have the for loop and the while loop. So we'll look into the for loop first, and let's make a program which prints the numbers from 1 to 100. A simple for loop would be for I, which is a variable in range 1 to 101, print I. This, as you can see, prints till 100. And you might have also noticed that I've given 101 here because it's similar to slicing. So it takes a start value, the range function actually takes a start value, and it takes an end value. So let's say range 3 to 8. So what the range function would do is it would make a list which would start from 3 and go on till 7. It would not make a list till 8 because the end value is never taken into account. So once this list is made, the I will first take the value of 3, then we'll take the value of 4, then we'll take the value of 5, then we'll take the value of 6, 7, and once it reaches the end of the list, the for loop will get terminated. So to illustrate this much better, so here if I've given range from 1 to 101, I would first take the value of 1, then it would move and take the value of 2, and so on till it reaches 100, and once it reaches 100, the loop terminates and the program ends. So the range function would make a list, say from, this would make a list from 1 to 2 and to 100. It wouldn't take 101 because the end value is never included while making the list. So to maybe shorten it. So to directly use lists, let's try this directly with lists. Let me declare a list which is, let me just take this list here. Let's copy this here. Okay, so to illustrate the range function better, it's equivalent to saying for I in range or for I in X, print I. So you can see that I first takes the value of the and the quick, brown, and it goes on till the end of the list. Once it's reached the end of the list, it terminates. To show that it terminates, we can maybe add a print statement at the end saying the loop has. So you can see once it reaches dog, the loop ends and it moves out of the loop and goes on to print whatever is apart from the for block. So the range function makes a list from the start value till the element before the end value, and that essentially I takes the value of the value of the list, and once the list ends, the for loop also ends. And you can also move through lists in this way by declaring a list, and for I in X would essentially the I would take the value of each element in the list. You can also try this with tuples. It would also work with tuples the same way. Tuple is parenthesis rather than square brackets, and a tuple is immutable whereas list is mutable. That's the only difference. You can't change the values in a tuple, whereas you can change the values in a list once declared. So for I in X would also do a similar thing, as you can see. And it's not necessary that you use I, you can use anything here. You can use A, B, it's your convenience. It's usual practice that I is always used, so hence that's why I used I. So another interesting question arises: what if I have a string? Let's say string is, and what if I loop through the string instead? So looping through the string, what it does, it prints each character in the string. Whereas for a list and a tuple, what it does, it prints each element in the list and not each character. It does not print T, H, E. It prints each element in a list or a tuple. Whereas for a string, what it does, it prints each character in a string. So that's the difference between you looping through a tuple, a list, and a string. So a tuple and a list, you would essentially be looping through each element in the tuple or list. Whereas in a string, you would be essentially looping over each character in the string. So that's the difference between lists and tuples to strings. So similarly as slicing, if you've noticed slicing, slicing as a start value, end value, and a step value. So range also works in a similar way. So this would mean, let's say, let me print till 10. So stick here. This will print the numbers from 1 to 10. What if I want to print alternate numbers? I would just, by default, the step value is set to 1. It's always by default step to 1. If I set it to 2, it would print every other number. So 1 and the next element would be skipped, it would print 3, the next element would be skipped, it would print 5. For every third element, I would change the step value to 3. So 1 is printed, 2 and 3 is skipped, moves on to 4, 5 and 6 is skipped, moves on to 7. And if I increase the step value to 4, every fourth number will be printed. 1 is printed, 2, 3, 4 will be skipped, then 5 will be printed. And similar to slicing, you can also take in negative values. So, but one thing that you have to remember is the start value is always end value. So meaning the end value also always have to be higher. So I could say 10, 3, subtract and go on. So sorry, let me just remove. Okay. So what it does is it prints the sequence in reverse. So keeping a negative step value would essentially print the whole sequence in reverse. So if I wanted to print from 10 in reverse order, I would say this, it would print in reverse order. And the same way, if I want to print every alternate number, I could just increase the step value to 2, and every third number in reverse would be 3. So, and interesting, if I do this, it won't print anything because 0 minus 1 would go to minus 1, and that isn't in the range. So this is not sensible to make a list because you're essentially going back from 0, and if you go back from 0, all you get is minus 1 and minus 2, but the end value is 10. So at the end of the list, you should reach 10. Whereas in this case, you would start with 1, 2, and 3 would be skipped. You go to, 2 would be skipped. You move to 3, to 4, and so on. So this doesn't make sense. So that's why the end value, the start value will be higher than the end value. So no, it starts from 10, goes on to 9, 8, and so on. So that's how negative step value and step values work in the range function. So I do understand it's a lot of things to take in because since it's new to loops. So I have a task for you. You'll be given a few minutes to solve it. So your task is basically, I want you to use a for loop to calculate the arithmetic mean of the first 100 numbers, and the output would be 50.5 because that's the arithmetic mean of the first 100 numbers. The arithmetic mean basically means I want you to add from 1 to 100 and divide by 100. That's essentially the arithmetic mean. It's the average. You could also call it the average of the first 100 natural numbers. So yeah, let me specify that. So I want you to start from 1 and add up to 100, and at the end, once you've summed up till 100, I want you to divide by 100. So I want you to use a for loop which loops from 1 to 100, and I want you to add each value. So you'll get a sum, and I want you to divide that sum by 100. Thereby you'll get 50.5, which should be the arithmetic mean of the first 100 natural numbers. So I'll give you like a few minutes to solve it, and let's look into how we'll be doing this. And oh yeah, and to answer your question, you can also use reversed. That would be like this. So using reversed would be, say, I think it doesn't work like this. I think you have to convert it. So the problem with reverse is I think you probably would have to, sorry. Okay, I missed the brackets. So you could I think you have to make it into a list again, because the normal reversed wouldn't work properly if you were taking an input from the string. So it's from the user. So it's better to use the slicing rather than the reversed function to solve the palindrome problem. By the way, if you guys have any other doubts, feel free to ask in 5 questions. I'll be more than happy to answer them. Oh, okay, you're a bit confused on how to add the numbers. So okay, I'll give you a hint maybe. So each time I takes a different value. So possibly what you could do is you could each time add I to a variable, maybe declare a variable like sum, and try to add I to this I to sum each time, because first time it takes the value of 1, 2, 3. So each time it takes a different value. So if you add it to a constant variable, I think you'd be able to get the sum of the first 100 numbers. That would be my hint to you in solving this problem. I'll give you guys a few more minutes to solve it. Yeah, you could use sum plus is equal to y. That would essentially be the solution of it. Okay, I think that should be enough time for your task. Okay, let's look into how I would be solving this. So it's easier to declare a variable which would calculate the sum of the first 100 numbers. So I'm going to call it sum, and for I in range I would say 1 to 101. If I say 100, it's only going to add till 99, so I would say to 101. And what I would do is I would say sum is equal to sum plus I. A simpler form of this would be sum plus is equal to I. What it does is sum is equal to sum. This is essentially what it does, but it's a shorthand operations to say, I'm sorry, I here, to say sum plus is equal to I. So what this would do is I would first take the value of 1, so 1 would get added to sum. Next I would take the value of 2, so 2 would get added. It will go on adding each number till it reaches 100. Once it reaches 100, it will exit the loop. So if you want to check it, we can maybe check the sum here. It shows 5050. That's the sum of the first 100 natural numbers, but we want the average. So we would say, you know, the average is not the average. The average would be dividing this by 100, because we have summed up 100 numbers, so the average of it would be dividing it by 100. That should give us 50.5. I'll give another task to make you guys more familiar with loops. So let's try to make this program more user friendly. So we now only calculating the arithmetic mean of the first 100 numbers. What I want you to do is same, using a for loop, calculate the arithmetic mean of the first n natural numbers, where n is a user inputted integer. Let's also assume that just put it in another line. N is greater than 0. We don't want it to be 0, because you know that you can't divide any number by 0. So in case the user gives 0 and we just do this, or it wouldn't work, nor the range wouldn't work, because you set it to 0, it wouldn't even take it. So let's just assume that the range is that n is greater than 0. So I want you to, so the output would be something like this. So you would ask for a number from the user, and if the user enters 30, for example, the average is, I think, 15.5, and the user enters something else like 76. I want you to print the averages 38.4, I think, if I'm not wrong. So it's just small modifications to the existing program of this. All I want to do is get an input n from the user, and I want you to, you know, sum up till n natural numbers, and once that's done, I want you to find the average of them. I'll give you probably like 3 to 4 minutes to solve these as well, and if you have any doubts or clarifications regarding this, you can ask them in 5 questions. The program is almost correct, except yeah, you divide it by 100. Well, I think you guys should be. I'll give you maybe guys 1 minute, then we'll look into the solution. Okay, let's look into how I would be doing this. Okay, so we declare sum is equal to 0 again, and we take an input n from the user, say number, and we go for I in range 1 to n plus 1. It's not n because that would mean that you're only adding up to n minus 1 numbers. So n plus 1 would essentially give you the mean of n numbers. You always have to remember to add the plus 1 so that you don't miss out on the last number. So the same thing as usual, we add I to this I to sum, and at the end say print the averages sum. So sorry. Okay, sorry, I forgot to pass this to, yeah. So make sure that you pass it to an integer and make sure it's not a string, because you can't add strings to integers. So that would give you 18.5, and I think maybe let's try 200. Yep, that gives us the correct answer. So what we're doing is we're taking in an integer n, we're passing it as an integer. So we're looping through n plus 1 and we're adding that to sum, and at the end we're just dividing the sum by the number of or the first n natural numbers, and that should give us the average. Cool. So that would make you more clear on the basics of loops here. So okay, so loops also have two handy statements. They're called the break and the continue statement. So let's look into what each one does. So the break statement, what it does is it terminates the loop in which it lies. To illustrate this, let's make a program to divide two numbers thrice. So I think it's pretty obvious that everyone here knows that you can't divide a number by 0. So it's impossible to divide a number by 0. Let me even try it. You'll get an error. You get an error saying division by 0. It's not possible to divide a number by 0. It's mathematically incorrect. So let's make a program to divide two numbers thrice. So what we would do is say for I in range 0 to 3. So this program will run three times. Let me just do this. So it will run for 1, 2 and 3. So this program would run 3 times. So 3 times, let's take an input from the user. Let's ask them for an enter number 1. Is int 2. So this range is just to run this loop 3 times. That's it. So we'll take in two numbers, and what we are going to do is we're just going to print, say, the result of them, the division of them, which was this would be it. Let me just okay. Okay, as you can see, the program runs 3 times, and 3 times we are allowed to enter two numbers, and the division of both of them are printed. So what if in the middle of running the program I for say divide by 0? It's gonna return an error, and it's gonna print this message. And we don't want the user to get scared by this message, a huge error popping up in front of the screen. So what we would do is, if a user tries to divide by 0, we're going to exit the program. We're just going to say that dividing by 0 is not possible, so we're exiting you out of the program, so that the user realizes that user has tried to divide by 0 and it's not possible to divide by 0. So what we check is, since we're dividing by b, we can just check whether b is equal to 0. We would just say if b is equal to 0, this is going to say print dividing by 0 is not possible. And we want to exit the program once this is done, because if we manage to if we just keep it like this, what's going to happen is when I try to divide by 0, it's going to say dividing by 0 is not possible, but also print this error here. But we don't want the error. We want to not run this line at all, because this is the line which essentially prints out the error, because we're dividing by 0 here. We don't even want the program to go to this line. We just want to exit out of the whole loop. That's where the break command comes in. So if I use the break command here, what it does is, once the break command has been hit, it automatically breaks out of the loop. So let's try running this program now. So I get the result here, and now let's try dividing by 0. It's going to say dividing by 0 is not possible, and it exits out of the loop. It's not going to ask me to enter the number again. So this is the use of the break program, the break command. The break command actually terminates the loop there and then when the command is executed. So wherever the break is, it's going to exit out of the loop. For say, if I put a break command here, the loop isn't even going to run, because I've just broken out of the loop in the first line. If I put it here, it's just going to ask for 2 numbers and it's going to break out of the loop there and then. Yeah, that's it. So the break command would be very useful in these cases when there's something illegal that's happening, or the input is not proper. We can just exit there and then out of the loop, so that the user does not get a huge error message there. So that's the use of the break program, the break statement, sorry. So let's see what the continue statement is used for. It's almost similar to the break, but kind of opposite in some way. So the continue statement, what it does is, once this statement is hit, or once the statement is run, all the code after the statement is in a loop, is skipped, and the loop moves to the next iteration. So iteration is the way of saying the loop moves on to the next number or the next element. So let me illustrate this with a simple program. So let's make a program to let's use the same program to divide 2 numbers. It's the same program, but this time I don't want the loop to exit once the user has entered 0. I want the user to still get a chance to finish entering his next number. So what I would do is, we would stick onto the same program, 1, 4, just copy paste it here. We take in 2 numbers as inputs, and if p is equal to 0, we're going to print, say, dividing by 0 is not possible. But in case the user in his or her first input itself by mistake put in 0 as b, we want to give the user 2 other chances, or to input maybe the next same correctly. So let's just, so using continue here, what it would do is, oh sorry, so let me try entering this. It works properly. So let me try dividing by 0. It's going to say dividing by 0 is not possible, but it's still going to give me the remaining 1 chance that I have of entering the number. So this program essentially allows me to enter two numbers 3 times, so it's still going to give me the other chance of entering a proper denominator to calculate the division. So even if I mess up in the first time and say I divide by 0, it's still going to give me two other tries that I have left to, so it's still going to give me 2 other tries to enter proper numbers to divide. But the continue statement, once it's been hit, what happens is any code after the continue statement which is inside the loop, this is the loop, for loop here, so this statement would never run, only after if the continue statement is hit. So to illustrate this better, let's say I put the continue statement here. So what would happen is, once the continue statement is hit, all this code won't even be executed. It would just go to the next iteration. Let's try running this. It will ask for a single number. As you can see, it goes back to this line. So all the code that comes after continue is not going to run. It's never going to be executed, and it goes to the next iteration where I takes the value of 2. It's going to ask me the number again, and it's going to ask another number, and that's it. It's going to end. So all the code after the continue statement is not going to be executed. So that's the role of the continue statement. So as this sentence says, all the code after the continue statement will be skipped and the loop moves to the next iteration. That's how simple it is. So what I'll do is we'll have a program which illustrates the difference between the continue statement and the break statement better. So let's say I want this is going to be the loop using break. So what I want to do is I want to print numbers which are divisible by 3. So I would say the first 10 numbers which are divisible by 3. So I would take this would loop over the first 10 natural numbers, and I would check if I divided by 3 is equal to 0. So to all those who don't know what the percentage stands for, percentage is essentially a modulus operator. So this returns the remainder after division. So to show this better, let me just, so if I say, the remainder is 1, dividing 3 by 2 is essentially going to give you a remainder of 1. So let's say I'll try dividing 7 by 4. It's going to give me a remainder of 3 because you can only divide 7 by 4 once and it leaves a remainder of 3. So the modulus operator returns the remainder of division. So essentially what this statement would do is it would divide I by 3 and it would return the remainder. So we want to check whether if number is divisible by 3. So if a number is divisible by 3, it's obvious that the remainder is going to be 0. So what we want to do is, if a number is divisible by 3, we're just going to break out of the loop. Else, if a number is not divisible by 3, we're just going to print I. Let's see what this does. It prints 1 and 2 because 1 is not divisible by 3, hence it's printed. 2 is also not divisible by 3, hence it's printed. But once 3 comes, 3 modulus 3 would give you 0 because 3 is divisible by 3, and it would exit out of this loop. Let's run the same program. What we'll do is we'll just change the break statement to the continue statement. I'm just going to copy the same program here. Just going to change one statement. This would be changed to continue. So let's see, it's not needed now. This I think would better illustrate the difference between the both. So what it does here is it prints 1 because 1 is not divisible by 3, it prints 1. 2 is also not divisible by 3, 2 is printed. 3 is divisible by 3, so this if block is true. So the loop does not get exited. What it does, the continue statement simply skips all this goes to the next I value, which is 4. 4 gets printed, 5 gets printed, 6 is divisible by 3, so 6 is not printed because use the continue statement here, so 6 is not printed, and it moves to the next value of 5, which is 7. 7 is not divisible by 3, it is printed. 8 is printed, and 9 is divisible by 3, so it's going to skip this and it's going to move to the next value, which is 10. So the break statement, what it did is it only printed numbers which are not divisible by 3, which is 1 and 2, and when the first number which is divisible by 3 is found, it just broke out the loop right in then and there. As the continue statement, what it did is for each number which is not divisible by 3, it's just going to skip that and move on to the next number. So I think this program would better illustrate the difference between break and continue. So I have another interesting task for you to do. So what I wanted to do is I wanted to create a program in which the user gets 3 tries to enter the correct password. It's a simple password program which I'm sure you all would have programmed, but the user gets 3 tries to enter the correct password. So the output would be like this. I want you to say enter password, and if the password is incorrect in this case, I want you to say the password is incorrect, and the user will get another try. So copy this here. So again, if the user gets it wrong, he or she again going to say it's incorrect, and the password actually happens to be just password, let's say, and I want you to say the password is correct. So if the user gets it by second try, I want you to exit out of the program then and there, and if the user gets it in the first try, I want you to exit out of the for loop. Another interesting thing that you could do, maybe I'll give you extra time to do this, I want you to also say you have 2 more tries in this case, and say you have 1 more. And it's not going to look into the grammatical aspect of it. It has to be you have 1 more try, but I will just leave the grammatical aspect for it now. And if it's correct, I just want you to its password is correct. I just want you to let the user know that the user has 2 or 1 more tries for it. Simple as it is. So I wanted to create a program in which the user gets 3 tries to enter the password correct, and each time the user gets it incorrect, I want you to say that you have so and so more tries left, and once he gets it right, I just want you to say the password is correct and exit out of the for loop then and there. I'll give you like 5 minutes to solve this task. If you have any doubts or clarifications regarding this or anything that I've thought before in this lecture or anything before, you can ask them in 5 questions. I'll be more than happy to clarify them. That's an interesting implementation of it. I think you could try to avoid the variable n. You can actually do the program without the variable n. Maybe try to finish the program without the variable n. I'll be going through the solution for it in like 2 more minutes. Exactly, could just use I. Okay, so I think that should be enough time for you guys to solve the task. Okay, let me go through how I would go about solving this. Let me declare a password or the key to the password, which is let's say pwd123. So for I in range 1 to 4, let's just say password is equal to, I would take password as an input from the user, ask enter password. Cool. So the first thing to check is the password matches the key. If password is equal to the key, we're just going to say the password, quotes, the password is correct, and we are in. Correct. And once that's done, it's no use of looping through the loop, so we're just going to make a break statement here. So the break statement, what it would do is it would essentially break out of the whole loop once password is correct. Else we're just going to print password is incorrect, and we can say you have 3 minus I tries. So the first time you will get 3 minus 1 is 2, so it will say 3 minus 1 try, and for the second time it would say 3 minus 2, which is 1. You would have 1 more tries. Let's give a spacing here, and we'll just move on to the next. So that's the program, pretty simple here. So it would ask for a password, and if I give the password straight away, it would just say the password is correct, you're in, and it will just break out of the loop. So that's the use of the break statement here. It's just going to break out of the whole loop once the password is correct. In case it's incorrect, let's say it's going to say the password is incorrect, you have 2 more tries. The 2 is calculated with this simple equation here. So I would take the value of 1 the first time, so 3 minus 1 would give you 2, so it's just going to say 2 more tries. If you manage to get it wrong the second time as well, it's going to say the password is incorrect, you have 1 more tries. It's grammatically wrong, but it's fine here. And finally, if I get it wrong again, this is where something it's going to say the password is incorrect, you have 0 more tries. It's not good to look at this, so possibly something that you can work on later is to change the program, so that it says access denied or something like that. It's going to be a simple condition. It's going to say, okay, if you want, let me just do it here. All you have to do is I happens to be 3, which is the last value. you can just print access denied and just break out the loop. This should work. So oh sorry. So yeah, so what it does is the final value of I would be 3. So rather than saying the password is incorrect, you have 0 more tries. If we are at the last stage or the last try of our password, you can just say access denied, which would be, you know, much more user friendly to look at rather than say you have 0 more tries. So this is a nice program to illustrate the use of both the break statement and the continue statement in a single program. So okay, so I think this should be enough for loops for this week. We just covered the basics of for loops. We'll look into more interesting programs with loops next week, printing patterns and all that sorts next week. So before we wrap up today's lecture, let's look at something called Python modules. Okay, so Python modules is essentially a file with a set of functions that you can import and use on a program. So we're going to look at the random module here. This random module will come in handy when you're solving for this week's homework. So first thing that you need to import a module is to, or use a module is to use the import statement to import the random module, which is import random. So as I said, a module is a file with a set of functions which you can import and use. This will be my simple definition for the program for a module. So to import random, we just import random. So random has this function called random dot randint. So a function is essentially your dot is alpha is a function, your dot reverse is a function, the sort is a function. All these are functions. But these functions are already imported when you run a Python program. There are a lot of different functions for performing mathematical operations, for performing statistical operations. So the random module basically has functions which you can use to generate random numbers and random sequences. So one such function which is inside the random module is the random.randint function. So the randint function takes in A and B, and what it does, it generates a random number x such that x is greater than equal to A and x is less than equal to B. In simple terms, it would mean a number within the range A to B. So in this case, it would generate a number which is equal to B, equal to A, or any number which is between A and B. Let's try it out. Let me just declare x to be a number and say random dot randint. Let's just get a random number from 1 to 100 and let's print the number. So it prints 85 now, printing it again 86, 91, 74. As you can see, each time it randomly prints a different number. So you keep on going, it's going to randomly print a number which is from A to B. So any number from 1 to 100 is going to get printed. So to illustrate this better, let's say for I in range 0 to 11. And then a number from 10 to 50, and just print the number. So it's going to randomly print 10 different numbers between the range of 10 to 50. So random function also has a lot of other unique functions that you can use. You can check them out at Python documentation. I'll add a link to the documentation in this week's lecture notes, which will be uploaded soon. Okay, so that's it for lecture 4 of Python, and this is random module. So yeah, a truly random function is hard. It's pretty hard. So I guess if you look more into cryptography, where random plays an important role, a truly random function is hard to generate, but Python has this unique algorithm to generate a random number. I'm not sure, maybe I'll look into it and let you know about how Python generates a random function next week. I'll keep that in mind. So, but a truly random number would be equal chances for every number. I think that is not possible in a computer program. That's what cryptographers are working into, and I think that's difficult to have it in Python. So I'll look into it and let you know next week. So you guys will have an interesting homework this week. You'll be building a guessing game. So using all those you've learned so far, including loops and random functions, you'll be building a guessing game. A guessing game is essentially a random number will be generated, and the user gets certain number of tries to find the number. And if the number is closer to the generated number, you can say that the number is close, and if the user manages to find the number within a certain number of tries, the user wins, and if not, the loser loses. So I think the homework will be uploaded in maximum a day or two's time. So I think you should be having fun in building a guessing game for this week's homework. So, and let's look at more interesting modules and functions, as well as interesting concepts regarding for loops next week. So that's it for this week's lecture. Yeah, and if you guys have any questions, you can ask them in 5 questions. I'll be more than happy to answer them. Yeah. Thank you guys.